2.3 polynomial identities. We're going to do the first part of that today, the second part tomorrow. We're going to use polynomial identities to factor and multiply more efficiently. Yesterday you multiplied and you had to use your box or you FOILed or whatever method you used, right? But today we're going to use it. We're going to have 4 different identities and you're going to identify which one it is, and then you're going to use it to make this more efficient. And then last hour they're like 28 to 51. If you're using the identities, you should just go right to it, right? You shouldn't have to think about factors of this that equal this. You shouldn't have to do that. So make sure you write down good notes.
Okay.
Okay, so the first one we're going to do is difference of squares. We have dealt with difference of squares before, haven't we?
Yeah.
Okay, but we're going to do a little bit more than just x squared minus 16. A little bit. Okay, so we have a squared minus b squared equals a minus b, a plus b, correct? Those conjugate pairs. Now, I can use it to factor, but I also can use it to multiply, can't I? If I see the right, can I go to the left?
Yeah.
Yes. If I see that conjugate pair, I can go right to the left. I just square both. So I have 25x squared minus 36y squared. So are both of those terms perfect squares?
Yes.
Yes. So 25 and 36 obviously are. Yes. What about x squared and y squared? Are those perfect squares?
Yes.
What about x to the 6th? Yeah, because anything you can divide by 2 is a perfect square. Is x to the 7th?
No.
No. Okay, so any even number exponent can be taken the square root of. Okay, so this rule says if I have a squared and then I have a, what did I do to get from a squared to a? Take the,
Divided by itself.
what is that called? Square root. I take the square root. So what is the square root of 25x squared? 5x. Does it matter which comes first, negative or positive? No. I always put the positive because then I would have a negative answer, positive answer, and it will go from left to right myself, but it doesn't matter. Okay? Then what's the square root of the second? 6y. So once we have the first quantity, the next one just needs to be its conjugate, right? So 5x minus 6y, and I'm done. So if I gave you what was on the right, should you be able to go to the left?
Yeah.
You're going to use these identities both directions, left to right, right to left. Now the next one we have is the square of sum. And I'm going to change this to sums / differences. My pen is all off. Just a second, guys. Okay, so sums / differences. Okay, and so the rule is going to be, this should be an A, not an S. A plus or minus. Okay, works for either one. So this is square of sums. The square is because you see the square on the outside, yes? And when I square something, I multiply it times itself. Yes? So it's A plus or minus B squared would be A squared, the same sign, so it'd be plus or minus. And then how do I get my next term? A times B plus B squared. Now it's always going to be plus B squared because even if B was a negative, when you square a negative you get a positive. Okay? So this works for the square of sums or the square of differences, both of them. So my example is 3x plus 4y quantity squared. So you see the sum, right? The square of the sum. So what's it tell me to do?
A squared.
A squared, so I get
9x squared.
9x squared. Then what? Plus.
Same sign plus 3 times c.
So 3
12.
times 12 what?
X, y.
Plus.
Plus 6.
B squared, which is 16y squared.
So if I did 3x minus 4y quantity squared, what would be the only thing different?
So the sign is right now.
The line sign here. So it'd be x squared minus 12xy plus 16x.
Have we learned
Wouldn't the last one be y squared?
Yes, it'd be y squared. Just got the squared, right? Thank you, Evan. Yes, we have done this a little bit, but now they're going to be throwing some x's and y's and just kind of a little bit. You should have done that a little bit. Okay, now we have difference of cubes. So a squared minus b squared, difference of cubes. So what does my rule say? I went from a cubed to a, so I took the cube root, same sign, cube root of b. Okay, once you have a minus b, this is your new, what you look at. You don't look at the original anymore. You got this, okay? Then from here, I take and square a, opposite sign, multiply the two together, and square b. So similar to the square of sums and differences, right? But that middle sign is the opposite on square sum, on difference of cubes. So take the cube root, same sign, cube root. I'm going to point so somebody knows what they're watching. Cube root of a, same sign, cube root of b. Square a, opposite sign, multiply ab plus b squared.
Okay, we can come back to the last one.
Mm-hmm.
Since it's already squared in the b, so why do we need 16 y squared when you just squared it? When you already squared it?
No, you have to square it. You haven't squared it yet. No, the quantity is squared. You haven't squared it.
The 4y got
You have to take 4y times 4y, which would be 16y squared. Yes?
Yeah, I guess so,
Okay.
4 times 4 and y times
yeah. Okay.
You gotta square both of
Okay.
them. Okay, is 8 a perfect cube?
4. Yes, 2.
2. Is 27 a perfect cube?
Yes, 3.
3. If you don't know your cubes, you're gonna have to figure them out.
Yeah, I got it.
Okay, is m cubed a perfect cube?
Yes.